Welcome to another episode of eTech, where all things related to the electrical trade, electrical theory, code, and installation have a home. Today's episode is dedicated to Table 220.55, that huge one-page table used to figure out the demand loads for ranges and other cooking appliances. This particular table is a favorite among test writers because the questions can be asked in so many variations. But as with all things code-related, there is method to the madness. This episode of eTech is brought to you by Audible.com. Get a free audiobook download and 30-day free trial at www.audibletrial.com/eTech. That's eTech without the dash. Over 180,000 titles to choose from for your iPhone, Android, Kindle, or MP3 player. To begin with, let's just take a look at the overall table. Each table in the codebook should, and some are better than others, have in its title the full description and use. By the way, in the 2014 softcover edition, this particular table is on page 72. Now, if you're using a different edition of the codebook, a different code cycle, or perhaps a hardcover edition, the table will be identical, still numbered 220.55, but be on a different page. Article 220 is where this particular table lives, and in general, this particular article is dedicated to load calculations for services and feeders. There are two types of calculations we could perform for dwelling units and multifamily housing. One is known as the standard calculation. There's also a different method called the optional calculation, and both of these have their merits, but a very different methodology. We're allowed to use whichever one of these two calculations gives us the lower overall value. However, we tend to run into trouble when we try to mix the rules for both methods together under a single calculation. So, where does Table 220.55 fit in? Well, this is part of the standard calculation. In the optional calculation, the nameplate ratings of all appliances, including those for cooking, are used, and then a demand factor is applied to the total load, whereas Table 220.55 applies demand factors directly. So what types of cooking loads are covered by Table 220.55? Well, the heading gives us the answer. Demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kilowatt rating. Looking at the body of the table, notice that the first column is merely the number of appliances we are working with. The table applies to a single stove in a one-family home, but it can also be used to calculate the demand load for a 500-unit apartment complex. It is very, very flexible. Columns A and B are given as percentages that are applied to smaller cooking units, those less than 8 3/4 kilowatts, whereas the third column, column C, is used most often. Note that this column is in kilowatts and not in percent. Why is this the most often used column? Well, let's go back to the heading. It concludes by stating, column C is to be used in all cases, except as otherwise permitted in Note 3. In fact, there are 5 notes to the table, and we will consider an example where each of these notes is to be used. Just because they're small in print does not mean that they are of little importance. Rather, they give instructions on how to use the table for specific cases. So let us start with the first in a series of test questions and then use the table to answer these. And in case you're wondering, there are 12 questions total, each asking about a different aspect of this particular table. The first question asks, what is the demand load for a single 12 kilowatt range? That is really the simplest question to answer using this table. Being that the range is 12 kilowatts means that column C is to be used, and there's only one unit. Therefore, the answer is 8 kilowatts. And that makes sense because even though all of the burners and elements in the oven make for a total of 12 kilowatts, it is highly unlikely that all of them will be used at the same time. And even if they are, there are thermostatic controls that will cycle and spread out the load. The second question asks, what is the demand load for 10 12 kilowatt ranges? Well, again, column C is to be used. For 10 units, the total demand load is going to be 25 kilowatts. At first, this may seem really quite light. But think about this. Not everyone cooks dinner at the same time. And it is even more unlikely that many will use their stoves to full capacity. Question number 3. What is the demand load for 30 12 kW ranges? Here again, column C is to be used, but the answer is given as a formula. We have to extend the table out a little bit. The formula is given as 15 kilowatts plus 1 kilowatt for each range. Seeing that we have 30 ranges, we could then write the formula as 15 kilowatts plus 30, for a total of 45 kilowatts. So our total for all 30 ranges will be 45 kilowatts. Now things are getting a little bit more complicated. Question number 4 says, what is the demand load for one 16 kW range? Well, at first this may stump people, especially if they struggle to understand Note 1. Note 1 underneath the table states, over 12 kilowatts through 27 kilowatt ranges all of the same rating. For ranges individually rated more than 12 kilowatts but no more than 27 kilowatts, the maximum demand in column C shall be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceeds 12 kilowatts. So the first step is to see how much bigger than 12 kilowatts your range is. In our case, it has an extra 4 kilowatts. For each of those, we need to take the table value and increase the given value in column C by 5%. So for one appliance, column C gives us 8 kilowatts. We are 4 kilowatts over the 12 limit. Hence, we need to increase the column C value by 20%. 8 kilowatts times 1.2 gives us 9.6 kilowatts as our final answer. Question number 5 then asks, what is the demand load for 10 16 kilowatt ranges? Well, the same methodology applies to multiple ranges. We are still 4 kilowatts over the 12 that the table is built for. Therefore, we look at 10 ranges in column C, which gives us 25 kilowatts, and then increase this value by 20%. Therefore, 25 kilowatts times 1.2 is 30 kilowatts. Question number 6 then explores the size going the other way. It asks, what is the demand load for 10 6 kilowatt ranges? Quite small, apartment size. This time, Note 3 applies. It reads in part, over 1 3/4 kilowatt through 8 3/4 kilowatt. In lieu of the method provided in column C, it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4 kilowatts, but not more than 8 3/4 kilowatts, and multiply the sum by the demand factor specified in column A or column B for the given number of appliances. The words here, in lieu of, it means instead of. Now, also notice the words that it shall be permissible. It does not say it shall be required. In other words, there may be situations where column C will still give a lower value than column B. That is not the case here, though. Remember that column B is in percent, and thus, when we multiply 10 ranges times 6 kilowatts times 34%, we get a total demand load of 20.4 kilowatts. Question number 7 then asks, what is the demand load for 10 8.5 kW ranges? And here is where you want to be careful. The permission to use column B is there, but will this give us a lower value? Let's compare. 10 ranges in column C give us 25 kilowatts. For column B, we take 10 ranges times 8.5 times 34%, and that gives us a total of 28.9 kilowatts. So in this particular case, using column B will give us a higher value. Use column C instead. Question number 8. A 10-unit apartment complex has 5 units with 3 kW cooktops and 5 units with a 6 kW range. What is the total cooking appliance demand load? Again, we go to Note 3, but here the latter half of Note 3 applies, and it reads, where the rating of cooking appliances falls under both column A and column B, the demand factors for each column shall be applied to the appliances for that column, and the results added together. So for column A, we have 5 times 3 kilowatts times 62%, for a subtotal of 9.3 kilowatts. Under column B, we take 5 times 6 kilowatts times 45%, for a subtotal of 13.5 kilowatts. And then we add both of these values together for a total of 22.8 kilowatts. Rather than looking at the load and the demand factor from the perspective of a service or feeder, question number 9 asks about the branch circuit. What is the minimum branch circuit rating for a 12 kW range? Now this is a bit of an anomaly. Article 220 is titled and designed for feeder and service calculations. And at a feeder or service, you have the full diversity of the load that is to be spread out across the calculation, which is why we can use demand factors. However, underneath the table, Note 4 tells us that we may use this same table for the individual branch circuit. It says in part, branch circuit load. It shall be permissible to calculate the branch circuit load for one range in accordance with Table 220.55. So, back to our question. We have a 12 kilowatt range. In column C, that gives us 8 kilowatts. 8 kilowatts, that's the same as 8,000 watts, divided by 240 volts will give us 33.3 amps. One further reference that's important here is NEC 210.19A3. Article 210 is dedicated to branch circuits. 210.19 gives us specific branch circuits, and A3 are for those that are ranges and dwelling units. And here it states that the minimum circuit for ranges 8 3/4 kilowatt or more shall be 40 amps. So our demand load is 33.3 amps, but our circuit can't be any less than a 40 amp rated circuit. Question number 10 continues on in that same vein. It says, what is the circuit load for a 6 kW wall-mounted oven? And again, Note 4 comes into play. A different part of it reads, the branch circuit load for one wall-mounted oven or one counter-mounted cooking unit shall be the nameplate rating of the appliance. And so there's no math involved here. Basically, the circuit load is 6 kilowatts or 25 amps at 240 volts. There is no derating for an individual wall-mounted oven or counter-mounted cooking unit. Question number 11, however, puts several of these appliances together in the same kitchen. It reads, a dwelling unit has 2 4 kW stacked wall-mounted ovens and a 6 kW counter-mounted cooktop. All 3 are fed from a common branch circuit. What is the demand load and circuit size needed for this branch circuit? Another part of Note 4 applies here. Note it states the branch circuit load for a counter-mounted cooking unit and not more than 2 wall-mounted ovens, all supplied from a single branch circuit and located in the same room, shall be calculated by adding the nameplate rating of the individual appliances and treating this total as equivalent to one range. And so we add the three cooking appliances together. We have the two ovens, 4 kilowatts plus 4 kilowatts, and then the counter-mounted cooktop, 6 kilowatts, for a total of 14 kilowatts. And yes, it is 2 more than 12. That means that column C, which gives us 8 kilowatts, needs to be increased by an extra 10%. 8 kilowatts times 1.1 gives us 8.8 kilowatts at 240 volts. If you divide that out, you get 36.7 amps. So a 40 amp circuit is still adequate. And then question 12. It merely asks the question, does this table only apply to dwelling units, or can it be used in restaurants? Well, we have a different section available for restaurant equipment, and Note 5 gives us the only exception to non-dwelling applications. It states, this table shall also apply to household cooking appliances rated over 1 3/4 kilowatts and used in instructional programs. So if a school has a home ec classroom with a bunch of ranges in it, those two can be calculated using table 220.55. So we had the 12 questions, but at this point, if you've been marking your code book, you realize that we did not cover Note 2. So here's a bonus question. Question number 13. This will cover Note 2. A 10-unit apartment has 5 units with a 16 kW range and 5 units with a 10 kW range. And to get the full instructions as to how we're supposed to treat these different units, Note 2 says over 8 3/4 kilowatt through 27 kilowatt ranges of unequal ratings. That applies in this case. For ranges individually rated more than 8 3/4 kilowatt and of different ratings, but none exceeding 27 kilowatt, an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. But note this, using 12 kilowatts for any range rated less than 12 kilowatts, and dividing the total by the total number of ranges. Then the maximum demand in column C shall be increased 5% for each kilowatt or major fraction thereof, by which this average value exceeds 12 kilowatts. So let's work through our example. We have 10 kilowatt ranges in 5 of the units, but we have to figure them at 12 kilowatts. 12 kilowatts times 5 gives us 60 kilowatts as a subtotal. And then we have the other 5 ranges at 16 kilowatts. 5 times 16 is 80 kilowatts for a subtotal. Add the two values together, and we have a total of 140 kilowatts divided by 10 ranges. So the average value here is 14 kilowatts. Now we go back to column C, where 10 ranges gives us 25 kilowatts. But our average is 2 over the 12. Thus, we have to increase our 25 kilowatts by an extra 10%. 2 over 5%, each kilowatt that we're over makes 10%. So our total demand load, 25 times 1.1, is going to be 27.5 kilowatts. Well, with those 13 questions, we were able to get everything that we needed for table 220.55. We used every single example and every single note underneath. Just remember that this table can only be used for the standard calculation, not the optional one. If you try to mix the two together, you will get the wrong answer. We certainly hope you enjoyed this episode of eTech, which is brought to you by Audible.com. Get a free audiobook download and 30-day free trial at www.audibletrial.com/etech. That's etech without the dash. You will have over 180,000 titles to choose from for your iPhone, Android, Kindle, or MP3 player. I'm currently listening to Paper, Paging Through History. It's written by Mark Karlansky and narrated by Andrew Garman. And what I find fascinating about it is that just as electricity has been driving our civilization forward, so too the discovery, use, and improvement of paper has propelled human thought throughout the centuries. Try this or any other audiobook for free at www.audibletrial.com/etech. That's etech without the dash. Thank you so much for tuning into this episode of eTech. Please visit us at e-tech.us, or for training in the Eastern Washington area, check out our classes at inw-training.com. And as always, links are in the description, and we will see you next time.